Hello viewers, this is Wagda Ronald taking you through today's tutorial for O-level physics, and this tutorial we're going to talk about mutual and self-induction. So these are the very questions I left in the previous video, and I believe by now you've already tried them out and ready to mark yourself and check your progress. So we are going to start with question 4, and this question was got from 2003 of UNEB paper 1, question 46. So part A says, explain briefly how a calculator which operates on 6 volts DC can draw power from a 240 volt main supply. So first we should say that the 240 volt main supply is first stepped down to a 6 volt AC. So this is AC to AC, but it has been stepped down. But remember they want DC, so what we are going to do, we shall come and say that the 6 volt AC is then rectified to 6 volt DC using diodes, which is what they want. So after that we shall now come and conclude and say that the 6 volt DC is then supplied to the calculator. So basically that's what they wanted. Now let's see how much can be awarded. Half a mark for stepping it down using what? Using a step down transformer. Another half a mark for rectifying, another half a mark for conclusion. So basically that's how the 2 marks could come about. So now we are going to go to part B. Part B says that state 2 sources of energy loss in a transformer. So one is the resistance in windings, or you can say ohmic losses or copper losses. Another one are the losses due to eddy currents. The next will be hysteresis loss, poor flux linkage, or magnetic flux leakage. So this is leakage, this is linkage there. Okay, so in that way any of the 2 is okay for you to get yours to save the 2 marks. So now we shall go to question 5, and question 5 was got from UNEB 1997 paper 1 of question 10. Now part A says that what is a transformer? So shall come and say that a transformer is an electrical device or machine used to step up or step down the voltage of an alternating current. So if you wrote that, that will be your safe 1 mark. Now shall go to part B. Part B says that a transformer whose efficiency is 80% has an output of 12 watts. Calculate the input current if the input voltage is 240 volts. So first of all you have to remember the formula for efficiency, that efficiency is equal to power output over power input multiplied by 100%. Now when we substitute where there is efficiency, you are going to put the 80%, which was given in the question. Then power output was given as 12 watts, so you come and put it there. Then power input is equal to IV, where V is already known as 240 volts, but IP is not known, which is the current in the primary coil, and that's what they want. So now that you have substituted, next is to make IP the subject. So when I make IP the subject, I'll come up with I being equal to 0.0625 ampere, and basically that's the current they wanted. Now let's see how marks can be awarded in this part. So half a mark for stating the formula, half a mark for substitution, and full mark for getting the current with the correct SI unit. So that's how you could get the 2 marks in that part. Now we shall go to part C. Part C says that explain briefly why bulbs in a building are connected in parallel. So one is to enable the system to continue working even if one bulb blows off. Another reason is to enable each bulb to be subject to the same voltage. Remember, connection in parallel, voltage is the same. The another one is to increase on their brightness. So basically that's what they wanted, and any two reasons is okay. So now we shall go to question 6. Question 6 was got from 1990 of UNEB paper 1, question 7, and part A says, give one reason why transformer cores are Roman 1 made of iron and Roman 2 laminated. So we shall start with Roman 1, why they are made of iron. So iron is a soft magnetic material. We have to first remember that, and therefore the core is thus made of iron core so as to reduce hysteresis loss. So hysteresis loss, you have to remember that hysteresis is the loss in energy due to turning the magnetic domains from one direction to the other as current changes. So since iron is a soft magnetic material, it is easy to magnetize and also easy to demagnetize. So basically that's why it is used. Then Roman 2, they wanted you to give a reason why transformer cores are laminated. So you come and say, first of all, for Roman 1, that is 1 mark, and now we shall go to Roman 2 and say that the core is laminated so as to minimize eddy current. So if you read that, that is also 1 mark. So now we shall go to part B. Part B says that a transformer has 200 turns on the primary winding and 300 turns on the secondary winding. A voltage of 1600 volt is fed to the primary. Calculate the voltage output on the secondary. So first of all, you have to know the relationship between voltage and number of turns. After that, we shall come and substitute. We know that voltage in the primary is 1600 as it was given. Number of turns of the secondary is 3000. Number of turns in the primary is 200. So now we are left with only one unknown, which is Vs. And when I come and make Vs the subject, I'll come up with the voltage which is required as 24,000 volts. So basically that's what they wanted in this part. Now let's see how marks can be awarded. So half a mark for quoting the formula, half a mark for substitution, and full mark for correct answer voltage with correct SI unit. So that's how you could get the 2 marks in that part. So I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another set of questions, but this time the questions will be on milliammeter as an ammeter. So that brings us the end of this tutorial video. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video with the solutions has been uploaded. Otherwise, thank you for watching, and also if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we all benefit as a family.